Alright, so this is my second video, and as before, I'm sure I'm going to make some mistakes, but I am demonstrating a growth mindset by knowing that each video I'm going to get better and my mistakes aren't something to be embarrassed about. It's just part of the learning process, so just bear with me, everyone. This video is going to be about exponent rules. Okay, so we're going to start with a basic review of how do exponents work. So if I have 4 to the third power, that means I'm multiplying 4 3 times. So 4 times 4 times 4, which is 4 times 4 is 16 times 4 is 64. If I have x to the fourth power, that's the same as x times x times x times x. So anytime I am using exponents, it's really just a shortened way of writing multiplication when we're multiplying the same thing over and over and over. Okay, so for my rules, let's say I have x to the third times x to the fifth. So really what this is saying is I have x times x times x. That's my first set. And then I have x times x times x times x times x. That's my second set. And when we do this, we can just really count them all up and write them in condensed form again. So that's 1, 2, 3, 4, 5, 6, 7, 8, x to the 8th. Okay, so that's really what we're doing. Now the shortcut, the rule that we can use is that we have 3 x's and another 5 x's, which gives us 8 x's total. So it's just really a shortcut, but honestly, if you want to just write it out, if that helps you, or picture in your mind the expanded version, that works too. But the rule just comes from the shortcut of doing the expanded version. All right, let's say we have x to the fourth divided by x to the third. Okay, so here I have x, 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 x. There's 4 x's on top, and 1, 2, 3 x's on the bottom. Now we know that anything divided by itself equals 1. So there's 1, there's 1, there's 1, and I'm just left with x. Okay? Or I could write x to the first power or just x. Okay? The shortcut version of that here, because I'm taking away the ones that match, we could subtract. So x to the 4 minus 3, which gets us x to the 1 or x. Okay, so again, this is just a shortcut. If it helps you to expand it out and actually see it, at least until you internalize it, that's a good way to go. Then we have x to the, let's say x squared to the third power. So this means I have a set of 2 x's 3 times, right? I have 3 of these. Everything that's in here, I have 3 of them. So I have 3 sets of 2 x's, which gets me 1, 2, 3, 4, 5, 6 x's. All right? Or the shortcut for this is x to the 2 times 3. 2 sets of 3 is 2 times 3. So again, it's x to the 6th. So there's my shortcut. If I have x over 4 squared, then that's this whole thing twice. So I have x over 4, or x divided by 4, times x divided by 4, which is x squared over 4 squared. Or you could write that x squared over 16. For my class, I'd accept either one of those, but different teachers have different things. So here, we're just taking this whole thing and literally just multiplying it. Remember, when we multiply fractions, we just multiply straight across the top and straight across the bottom. Let's see, we have, okay, let's think about this rule again. So what if I flip it? What if I have x to the third over x to the fourth? So now I have x times x times x over x times x times x times x. Okay, well again, if it matches, it just makes 1 with division. So I am left with 1 times 1 times 1 is 1, and this is just an x left on the bottom. Okay, but if I use my shortcut like I did up here, if I were to say x to the 3 minus 4, then I would get x to the negative 1, which is why x to the negative 1 is the same as 1 over x. Right? It equals the same thing depending on how we get to it. So when we're looking at these negative exponents, what it's really saying is, oh, it was left in the bottom. The one x that was left was in the bottom of the fraction. Let's say I have x to the 3 over x to the 3. So here I have x, x, x over x, x, x. This is 1, this is 1, this is 1. So I end up with just 1. But if I use my shortcut, then I have x to the 3 minus 3, which is x to the 0. So this is why anything to the 0 power is 1, because really what this is saying is, oh, I have the same number on the top and bottom of a fraction. They all divide to make 1, so I'm just left with 1. This is where x to the 0 comes from, is that idea of dividing to make 1. So it equals 1. Let's see, I'm trying to think, did I skip any rules? Okay, so let's do some practice. Let's say I have 3x squared to the 4th power. Sorry, let me get that in the screen. So this is going to be 3x squared times 3x squared times 3x squared times 3x squared, which is 3 times x times x times 3 times x times x times 3 times x times x times 3 times x times x. So you can see we can write this out in expanded form, but it's pretty long and tedious, which is why knowing those rules can sometimes make things a little easier. But in my expanded form, I see that I have 4 3's, so 3 to the 4th power. And I have 1, 2, 3, 4, 5, 6, 7, 8 x's, so x to the 8th power. Well, if we were to use the shortcut rule, we could just go, this is 3 to the 4th, x to the 2 times 4, which is 3 to the 4th, x to the 8th. It's a really bad 8. Okay. And we could leave it like this, or 3 to the 4th is 81. X to the 8th. Either one of those is acceptable for my standards. Yeah, I think that'll be the end of this. This is just kind of the basic beginning video.